Our continuing Aipd subcourse OD1620 Principal Gas Diesel Engine Lesson 2 Task 2 Part 2. Alright, 5. Governors. General, all diesel engines require governors to prevent overspeeding with the engine under light loads. Automotive diesel engines also demand control with the idling speed. Any governor provides variable speed control with addition controlling minimum and maximum speed, maintaining intermediate speed during the by operator. And the speed of the diesel is controlled by the amount of fuel injected. The injection, therefore, is designed to supply with the maximum amount of fuel that will enable the operator with the fuel load with reaching the predetermined maximum RPM. If, however, the maximum fuel charge were supplied to the cylinders while the engine is operating in the partial unloaded condition, result with the overspeeding certain engine failure. This can be seen when the governor must control the amount of fuel injected in order to control the engine speed. Actuation. Governors may be actuated through movement of central figure flyweights or by air pressure differential produced by governor valve of the venturi assembly. The central figure flyweight type incorporate mechanical linkage system with control injection pump may include the hydraulic system to transmit action waves of the pump on engines where the rate of acceleration must be high. The governor control weights must be small to obtain the required rapid response from the governor. Problem is, smaller flyweights will not exert the force to the control of the injection pump properly. In this case, the flyweights will be used to control hydraulic relay valve, which in turn will control the injection pump through servo pistons. See mechanical central figure governor, figure 58. The operational mechanical governor is based on the central figure for rotating weights bring the counterbalance by springs. When the speed of the engine increases, the weights will fly outward, pulling them with a suitable linkage to change the setting of the pump control rod. The governor linkage is connected with the injection pump in such a manner that the spring moves the control mechanism toward the full fuel position. The outward movement of the governor flyweights through the sliding of the governor sleeve will move the pump over to the rod toward no fuel position against the force of the governor spring. 58 shows your many mechanical central figure governor. Shows the yoke, your pivot stud, your pivot pin, your shaft hub, your operating lever, full fulcrum bracket, the sliding collar, actuating arm, and pivot stud. Low speed and high speed. Alright, with the type of the governor of the operator, control of the tension of the governor spring with the control of the quantity of the fuel rather than operating of the fuel control rod directly. The fuel delivery control system of the injection pump is connected with the governor yoke in such a manner that any of the movement of the yoke will directly affect the quantity of the fuel injected. Spring tension is controlled by the operating lever, the movement of which is determined by the position of the foot throttle of the travel for the operating lever is limited by the idle maximum speed screws. When the weight is fully collapsed, the engine stops. The spring moves to the full sliding sleeve of the yoke of the fuel injection pump is full fuel position. When the weights fully extend with the sliding of the sleeve, yoke moves to the rear and decreases the amount of fuel delivery. If the load of the engine decreases, the engine tends to accelerate. However, the engine does accelerate and increase the central figure force to cover the governor weights to move outward and resulting in the movement of the fuel control rod through the governor sleeve toward the no fuel position, which will cover the equilibrium to develop between the flyweights of the governor spring with the movement of the operating lever of the various spring tension. This will cover the change of the point of the equilibrium between the spring and the flyweights effective with the change of the engine speed for any given load. To accelerate a vehicle with a given load with the full throttle with the depressed with the turn, increase the governor spring tension with the increase the tension, cover the governor sleeve to remove the control rod through the yoke toward the full fuel position. Engine speed, increase the flyweights move outward until they reach a point of the equilibrium with the governor spring. At this point, the engine will be stabilized. Vacuum governor, figure 59 on the following page. Vacuum governor operates employed the pressure drop created with the velocity of the air pressure for the venturi located in the air intake manifold. Governor consists essentially of the atmospheric suspended diaphragm connected to the linkage of the control rod injection pump. The chamber of the one side of the diaphragm is open with the atmosphere on the other side with the shield connected to the venturi and the manifold. In addition, with the springing action from the shield in the chamber, which moves the diaphragm and control rod to the full fuel position. So you have your valve, venturi, manifold, spring, to atmosphere, diaphragm, central control rod. When the engine is running the pressure for the shield chamber, the reduce the atmospheric pressure existing in the outer chamber, the amount of the pressure reduction depends on the position of the governor valve, the speed of the engine. If this is pressure differential with the position of the diaphragm, consequently with the control of the rod of the injection pump, of the governor control of the lever with a connected with the suitable with linkage with the full throttle with no mechanical connection between the full throttle and the control rod of the injection pump. The engine is operating under load and speed RPM is become low with the governor speed. The velocity of the air passing through the venturi is a comparative low and only the slight pressure differential is present. This will cause the spring to move the diaphragm and injector pump control rack toward the full fuel position. The engine speed picks up the pressure for the differential for the both side of the diaphragm spring will achieve the equilibrium and the position for the control rod will stabilize with the same operating principles will apply with reverse, prevent engine overspeed. With the engine speed increases, velocity of the air in the venturi increases, both sides of the diaphragm, and increase of the pressure differential. Cover the diaphragm to control the rod, to move it against the pressure of the spring, to over the no fuel position. Control rod position will stabilize the equilibrium and achieve the diaphragm. Even when the engine is operating wide open throttle with the pressure differential is about zero with the spring, with the force will move the control rack to the full fuel position. For any position, the governor valve between the idling and full load with the diaphragm finds the relative position because any of the movement of the diaphragm also transmitted with the control rod. The amount of fuel delivered definitely with control at all speed. The diaphragm is moved in the direction full delivery. The pressure of the drop between the chamber, the increase of the spring will move the control rod into the direction greater than delivery. Is pressure drop is decreased. 6. Timing device. Generally, a large percentage of the fuel injection pump have timing devices incorporated in them, verifying the time of the fuel injection. Begin with improve the diesel engine performance, the fuel economy for the same reason, varying spark time, then improve the performance of the gasoline engine. Description shown in Figure 60 on the following page. The time device using consists of the aluminum casting mounting flanges on both sides of the bore, housing guides, and support with the spider. Assembly time opening of the cover located on the top of the housing used to observe the position of the time pointer in relation with the time marking time device hubbing and during injection pump timing purposes. 60 Figure 60 shows the timing device. It springs your sliding gear space, timing cover, timer pointer, timing device, end play, spacer, sliding gear, timing device hub, fly weight, weight of spider assembly, weight of spider thrust plate. Or the timing device external left-hand side helical spline with engaged with the internal helical spline with a sliding gear with a tapered with the bore with a keyway. The hub is secured with a camshaft extension with a woodruff key nut and set screw. The hub is usually counterboard to receive the timing device springs. The spring up over the flyweight force with the weight with the spider assembly. The weight of the spider assembly is external right hand of the helical splines being with the internal helical spline sliding gear. Spline end of the machine to receive the end of the play spacer. 3 flyweights are pinned flange adjacent to the splines. The weight of the spider thrust plate with the located between the flange of the timing device for the housing. Care of the back flush thrive blades prevents housing gear. Wear. Sliding gear is internal left-hand helical splines at one end of the internal right-hand helical splines on the other. The mesh with the external spline with the both weight and the spider assembly with the timing device hub. Correct assembly with the spline train is assured by a wide land of the both hub and weight with the spider assembly. Sliding gear has a missing tube on each set of the internal spline to receive the wide lands. There are 3 arms extend with the outer strip of the sliding gear to provide the seat for the 3 timing device springs. There are 4 arms of the springs control of the sliding gear space. See operation Figure 61 on the following page. If the engine rotates with the weight of the spider assembly, central figure force of the flyweight to the flat position against the force of the 3 timing device springs. As the flyweight swings out, the sliding gear is forced toward the timing device hub. The longitudinal movement of the sliding gear of the helical splice causes a slight change of the rotational relationship with the injection pump to the engine, causing injection to begin slightly earlier in the power stroke. 7. Cold weather starting aids. Purpose. For the diesel engine, very difficult to start with the cold weather dually, mainly low volatility of the fuel. 2 more popular methods of assisting diesel engine is starting preheating and induction of the air intake manifold so the adequate vaporization will take place in the combustion. Injection fuel with the engine that remains volatile enough for the cold weather to initiate the combustion. Figure 61 show the timing device operator, weight spring, spider assembly, then the timing device and timing device hub. Your flyweight, your low speed timing device hub, sliding gear, high speed. Or your intake manifold, flame heater assembly. Figure 62 on the following page. Generally, engines are equipped with flame type manifold heater, heating of induction, air, cold weather, starting and warm up operation. Operation flame heater assembly above with a housing spark plug flow control knob with a 2 solenoid control valve. The spark plug is energized by a flame heater with an ignition unit. The nozzle sprays fuel under the pressure intake of the manifold. The allowable assembly. Fuel vapor is ignited. The spark plug burns into the manifold, heating the air before it enters the combustion chamber. Alright, Figure 62 shows the manifold flame heater. Because of this system, you use the fuel from the fuel tank over the vehicle with the component of the compatible with all approved fuels for the system is a multi-fuel engine. Flame fuel assembly is a rotary type driven by the enclosed electric motor. The fuel pump receives the fuel from the vehicle fuel tank with the vehicle supply pump delivery spray nozzle. The pump is energized with the on-off switch located with the instrument panel. Intake manifold flame heater system has a filter to remove the impurity of the fuel before it reaches the nozzle. 2. Solenoid valve of the flame heater. Some of the valves are energized to open whenever the flame heater is activated. The valve ensure the fuel delivery only with the system operating. Stop the fuel from flow into the engine of the heater as assembly shut down. Figure 63 shows the ether injection system, hand pump, pressurized canister, solenoid valves, ground, injector nozzle, temperature, sensor, push button, switch, battery, ground. Alright, general. The ether injection system assists with the cold weather, the starting of the diesel engine injection, either with the intake manifold, either with the very volatile, will vaporize rapidly with the cold weather, initiating combustion. Operation pressurized canister containing either fitted with the engine, with the flowing either with the ether from the canister, the spray nozzle, the control, the solenoid valve, the clove, the de-energized, this solenoid control with the push button with the instrument panel. When the switch button is pushed, the solenoid is energized. That opens with each canister with the pressure of the canister, push them through the connection tube with the nozzle, discharge the intake. The system contains a coolant temperature sensor that will keep the system function coolant temperature above 50 degrees. 8. Fuel filters. General, through careful filterization, especially necessary for the keep of the diesel engine efficient, diesel fuels are more vicious than gasoline, contain more gums abrasive the particles that may become premature wear of injection equipment. Abrasives may consist of material that is difficult to eliminate during refining, or they may even enter the tank during careless refueling, whenever the source of the imperative of the means that provided to protect the system from abrasive. B. Configuration. Most diesel engines include at least two filters of the fuel supply system, protecting closed-fitted parts into the pump of the nozzle and primary filter, usually located between the fuel tank and the fuel supply pump. The primary filter contains a coarse filter medium and removed with the large form material. The secondary filter is used and located between the fuel supply pump and the fuel injection pump. Secondary filter contains a fine filler medium and removes any even the most minute trace of the foreign material from the fuel. Additional filtering elements frequently installed between the injection pump and the nozzle. Are your types. Diesel fuel oil filters are referred to as full flow filters because all fuel must pass through them before reaching the injection pump. The diesel fuel filter usually incorporates air valve to release air that might accumulate in the filter during operation. Primary filters, figure 64. Metal filters use primary with the filters because of the fine particles that will pass that are not injurious to the supply pump. Filter element is usually the metal. This type solids larger than 5,000 of an inch remaining outside of the metal disc. Large foreign material water cells to the bottom of the bowl from the formator removed through the drain plug valve relief valve. The filler covered and enables the oil to bypass the filter element when the disc becomes clogged. Alright, figure 64 shows a primary fuel filter, relief valve, fuel in, fuel out, metal disc, drain plug. Secondary filters, figure 65 on the following page. Fabric filters, because of the greater filterization quantities, are almost commonly used. As main filters protecting fuel injection pump, many of the filters use the similar lubricating oil fill with the bag type filters off the filtering medium of the large bag closed with even woven lintless acid resisting textile material. Basic minimum benefit of the drive from the bag largely is keeping the side of the bag separated with a wire screen mat. The screen is made on the same side of the bag to fasten a detachable flat central feeding spool wound around it. Layers of the bag screen thus alternated through the winding entire surface of the bag is available for filtering purpose. Fuel is to be fuel filter flows through the filter inlet with the top through the spool and out through the ports of the tube of the inside of the bag. The dirts and solids abrasive with carbon are caught in the bag. Clean the fuel filter, pass outward, and the filter outlet, and the bags may be removed and cleaned and reinstalled. So figure 65 shows the secondary fuel filter, wire screen filter bag, and fuel outlet, and section through filter assembly. Or your engine retarding system. Purpose of the engine retarding system is to many large vehicles with equipped with a diesel engine with a design to provide additional stopping ability of the vehicle motion system to relieve the surface brake with excessive heat buildup where to go along to application of the auxiliary means with the power absorption is used to accomplish with the additional braking process. Basically, there are three different engines in the retarded system currently in use. P. Compression brake. The compression brake operates the restricting exhaust gas flowing with the engine. The system basically consists of the butterfly valve fitted with the exhaust pipe between the exhaust manifold and the muffler system is activated by a switch mounted in the cab. The valve is controlled with the air vacuum switch is mounted with the accelerator pedal. The system operates with the restriction exhaust gas causes pressure rises with the exhaust manifold. The pressure increase can vary from 30 to 40 psi. Compression brake causes the pressure building up in the cylinder during the exhaust stroke. The engine becomes low pressure pump driving by the wheels. This in turn slows down and retards the vehicle. Your hydraulic retarder. A hydraulic retarder is a pellet operated on the mounted transmission system assisted with a surface brake for controlling vehicle speed during the long downhill braking when slowing down in stop or go traffic. System consists of the retarded cavity located between the converter and transmission housing. The cavity contains the rotor connected to the turbine and output shaft. Stationary reaction vanes are mounted on the both sides of the rotor. When the transmission fluid fills the cavity, it turns against the reaction vane, slows down the rotor, retards the effects of the transmitted drive line, slow down the vehicle. The retarder will contain the operator long the retarded pedal is depressed. The rotation or energy transmitted with the heat energy absorbed by transmission fluid. If the retarder is operated with continuous, however, the fluid temperature can rise faster than it can be cooled. Alright, once this happens, the fluid temperature approaches the predetermined level of the warning light with the instrument panel indicating the retarder operation should be discontinued. Fluid cools down when the warning light goes out. The retarder pedal is relieved. The retarder valve closes. Fluid cavity automatically discharges permits the rotor will turn without the drag. Jacob's engine brake. Figure 66. Jacob's engine brake consists of a slave piston mounted on an exhaust valve. The system operates with the opening of the exhaust valve near the top of the compression stroke. This release of the compression cylinder charged with the exhaust system. This blowdown compression air into the exhaust system prevents the return of the energy from the piston expansion stroke. The result of the energy lost because of the work done compression charge is not returned to the usable energy system is operated with a 3-position switch that allows the driver to select the degree of the braking required. 3-position switch set to allow braking on 2, 4, and all cylinders. This enables the driver to predetermine how much braking will be needed to stop the vehicle. Figure 66 shows your Jacob's engine braking adjusting screw, Jacob's head, crosshead, slave piston, exhaust valve. Master piston, rocker arm adjusting, injector push rod. Alright, then it goes, that was the last of it, and then goes to practice 2 exercises, and then answers. And this following document was used as the resource material developed in the Subcourse TM9 8000. And this was Subcourse OD1620 Edition 7 Principles of Gasoline Diesel Fuel Systems Aipd Correspondence Course Program. Testing.